Welcome back. Let's do some code. So I've simplified the scene, not that it was very complicated anyway, but it's now just a cube, and I've also brought the console window out because we're going to need that. To find it, just go to Window at the top and choose Console down at the bottom. Then dock it wherever you want it. It's just going to be used to pop up a couple of little messages from our code. And let's get to it. So we're going to right click in the project panel to create something. And we're going to create a C# script. So we're going to be using C# over JavaScript. You could look into the JavaScript option if you really want to. Personally, prefer C#. I think it's a better language, so we're going to go with that. And let's give it a name. Let's call it test. So this is our test script, and press enter to finalize the creation of that. We get a little preview of it over in the inspector, so you can see that there's already some code in there. We can't actually edit it there though. So what we're going to do is double click on it, and it will load up by default in MonoDevelop, but you might be using something like Visual Studio if you want to, or anything else that would let you edit it. Basically just a glorified text editor anyway. Okay, so let's break down what's there for us already. At the top we've got two lines that start with the word using, and that's telling the compiler, the thing that puts all this together, that this class is going to use some code from another place. So we're going to use code that's linked to the Unity engine, and that lets us do all sorts of stuff related to Unity. The second one says we're going to use some code from system.collections, and that's not specific to Unity, that's more a C# thing. So we're going to be using bits from Unity, bits from C#. That's really all you need to worry about for now. Line 4 is where we get to actually creating our class. So we've got a public class. Now the word public there is known as an access modifier, and that determines who can use this class. And by public, it means everybody. If something's public, we can all use it. Class just explains it's going to be a class. A class is like the blueprint or DNA of an object, a potential object. So a class on its own is not the object, but it potentially could be. Then we have test, which is the name that we made up, and the colon mono behavior bit explains that our class extends from mono behavior. It's based on mono behavior. So mono behavior is an existing class that all Unity components are going to be based off. And we basically pull in all of that behavior and we build on top of it. So we can already do everything a mono behavior can do, and then we're going to add our own things as well. If you ever want to know more about something in this window, you can actually double click on it to select it, and then use Command or Control and the apostrophe key, and that will fire up Unity's own documentation with the search term of the word you had selected. So we could then just click on mono behavior. There's loads of information that we're not really going to worry about just for now, but we can see there that mono behavior is the base class for every script. That's pretty much it. Everything we do is going to be based on it. Then we have a curly bracket that's the start of the class. We have a corresponding closing curly bracket at the bottom that explains when this class finishes. So everything between those two brackets belongs to the class. Line 6 is what's known as a comment. So 2 forward slashes there starts a comment, and that lets us write in plain English. It's a good way to explain what your code does, especially if you're new to it. It's like writing little guides for yourself. It basically means that 2 slashes means that the rest of the line isn't compiled, doesn't count as code. It can be anything you want. For now, I'm going to get rid of it. We've then got void start, and this is what's known as a function. You might sometimes see it as a method. And a function is a collection of commands given all under a given name. So in this case, the name is start. And the word void itself actually means nothing. So what this normally would be is the type of information you're expecting to get back from a function. And in the case of start, it gives us nothing back. So we say it's a void. It gives void information back, nothing back. And then the brackets are usually where you would put or request extra information for this function to run. And again, start doesn't need anything. It doesn't give us anything back, and it doesn't need anything to run. So there's no extra information in there, and there's no return type. We then have curly brackets for this particular function, and everything that belongs to start goes between them. So anything we type in here will happen when the object first spawns in the scene. Underneath we've got another function called update, and as the comment shows, this is going to happen once per frame, and that's heavily dependent on the user's computer. So there's no guarantee that this is going to update the same amount of times on one computer to the other. So you've got to use a bit of trickery if you want this particular function to be consistent across all machines. But same process again, it doesn't give us anything back and it doesn't need any information. It's just a clump of commands that are going to happen every frame. So that's the base code in a nutshell. Let's actually do something. So in here in the start function, I'm going to make use of the debug class. So this is another class, a class that already exists, and it's got what's known as a static function called log. A static function means we can use it without actually having to make an instance of the class. So what I said about the class being like a blueprint or an outline, that's true for the most part, but there are exceptions to it, and log is one of them where we can use it without actually making an instance of the class. So we're going to do debug.log, and then when I open a normal bracket this time, you can see that it's requesting a message from me. So this is the message that I want to pop up in the console in Unity, and I'm going to just write in quotes, good old hello world. Close the quotes, close the bracket, and then finish the line with a semicolon, and notice that it tabs in. We have this level of indentation to show how far into brackets we are, how nested we are. So we've got the class starts at no indentation, and the function is indented by 1, and then because we opened another set of curly brackets at the end of the function, we indent debug.log twice. Let's save that, jump into Unity, hold our breath and hit play, and nothing. So it's not quite working, and that's because for the most part the class does nothing without being attached to some sort of vessel. So sat here in the assets folder, this test class is doing very little. It's just the potential for an object. So what we need to do is assign it to an object, and that's why I've kept this cube in the middle. We need to attach it as a component to this cube, and we can do that by dragging it straight on in 3D, or we can throw it into the inspector there. You can see as soon as we put it on, we have this test script attached as a component. So now, when we hit play, we get hello world. Very good. So that's the start function and the debug.log function. You might want to make some use of that. It's very handy when you are sort of trialing stuff out. It might be that you want to log out the character's health when they get hit, just to make sure they're losing the right amount. You want to trace out when they've died or something like that, or every time you shoot you want to know how much ammo is left in the gun. It can be quite a handy way of just testing stuff quickly without having to build a UI. I'm actually going to move it down though. I'm going to drag it down here. Oh, it's going a bit crazy. Let's just undo that and cut it. Cut it from there, paste it there, and let's just change this. So instead of hello world, it's going to say update this time. So save that, make sure you save it, otherwise it won't take effect. Jump back to Unity, hit play, and now we just get spammed. So we can see that that function is actually happening quite often. And if I stop there, we can see it happened 318 times in those few seconds. So that's quite a lot of code execution. And this is where the bulk of our game logic will probably end up, because it happens so often. It's a good place to update, move characters around, check if they're dead, check if they've been shot, or whatever your game's going to do. So yeah, I'm going to keep the debug.log, but I'm actually going to change it now. Just one final little bit before we finish this video is that we're going to make use of a variable. And a variable is a way of tracking your own information. So we're going to make one. I'm just going to give myself a bit of white space. Extra lines aren't going to break your code, so if you ever want to space things out, just go for it. It's maybe a bit too much, but never mind. And we're going to make a variable here, so let's put a comment, make a variable. Need 2 slashes for a comment. And if you've ever watched any of my videos in Flash, you've probably come across the word var. So traditionally we would write var to make a variable. Now that's not the case anymore. We don't do that in C#. We actually need to tell this variable straight away what sort of information it's going to hold. And this is good because it keeps us on the ball, make sure we are using the right sort of variables. And in this case, we're just going to use a full number, also known as an integer, and the keyword for that is int, integer. So that has made a variable that's going to be an integer, and now we just need to give it a name. So let's call it number. And we can give it a starting value, so we can put equals 0. So we've made a variable called number, and we've told it to start as 0. And now instead of logging out update, I'm going to log not 0, I could just type 0, but we want to use that variable. We want to put the variable name, so we're going to log our number variable straight out. So save that, jump to Unity, and let's make sure it actually works. And you can see we get lots of zeros this time. Let's try and spruce it up a bit. So with this update happening so often, it might be a good idea to make this variable change every frame. So instead of just logging it out straight away, let's make the variable bigger. So the logic here is we make a variable, we make it bigger every frame, and we log it out. So to make it bigger, let's type its name. So to access it by typing its name, and notice it now appears in the predictive code. Number equals number plus 1. So we're saying number equals itself plus 1. So it should get 1 bigger every frame, right? Let's give it a try. And hit the play button. And so now it is bigger. It's bigger than 0, definitely, but it's not getting bigger over time. And the reason for that is the thing known as scope, the scope of our variable. And look at the logic of it here. This function happens every frame, and the very first thing it does is make this variable. So if we're making the variable every frame, it's obviously going to start from 0. What we need to do is make this variable somewhere else so that it's persistent every time this update happens. So next time we run it, it goes to 1 and 2 and 3 and so on. So we want to make the variable outside of it. So let's chop it from there. And we'll put it up at the top before all of our functions, just to keep it nice and organised. So now the variable is made outside of the functions, so it should hopefully last longer than the time it takes to get from this bracket to this bracket, because it's being discarded every frame, made and discarded every time. Let's save it up and hit play. And now you can see that that variable very quickly gets very big. Stop it, and just to double check, you can see that the last number it gave me was 269, and we can see that the number of logs we've got there is 269. If your log is getting very long now, you might need to click this clear on play button, just so it wipes itself every time you hit the play button. So that worked, and that's pretty much all I want to go through for this video. Very basic, but if you've never coded before, you've got to start basic. You've got to learn to crawl before you can run. So I will see you in the next video. We'll get a little bit more practical.